Hey guys, today we are going to start solving quadratics by factoring, okay? So solving so far, we've done that with graphs, and that's fine, right? We can certainly do that, but it's a lot of work to graph, and factoring is a lot faster. So we're gonna take our equations, no matter what they are, our quadratic equations, and we're gonna factor them and solve, and that's our solution, right? That's our solution set. Now, I know most of you are pretty comfortable with this, so I'm just going to remind you of some examples in this packet, and that's it, okay? So, and there are steps here, moving all terms to one side, like that's important to recognize that you have equal to 0. Then you're going to do your typical factoring, and we all have different strategies on how to factor. And then set each factor equal to 0 and solve. Write your solution set with those beautiful butterflies, and with a comma in between. It should not be parentheses. So when I have two terms, that either means difference of squares or greatest common factor. In this case, it's greatest common factor because I have x squared and a 9x. That means I have an x in common in both. So I'm factoring out an x, and I'm left with x plus 9 equals 0. And from there, because I have two different values when I multiply equals 0, that means that, I hope this is still recording. Yes. Okay, sorry. I got that a little alert. Got me nervous. So that means that x equals 0 or x plus 9 equals 0, because the only way to get 0 when multiplying, one of them has to be 0. And in math, in these cases that we're dealing with, it's an and scenario. So typically you don't write and, but you're welcome to do so. I usually do have a space in between and then solve for them. Well, x equals 0, there's nothing to solve. And then x plus 9 equals 0. Oh, that means x equals negative 9. So my final answer is x equals the solution set. I like to go numerically in order, so I'm going to switch that to negative 9, 0. And that's my answer. Similar idea with number 2. Number 3 and 4 is what I was talking about with that difference of squares. I have two values, but I don't have anything in common, right? There's no greatest common factor. So for a problem like number 4, let's go to, I'm looking there. I have to have difference of squares in order to factor this. Otherwise, it's not factorable. We have to use another method. So difference of squares states that if you have something squared minus something squared, that you can change that into, I should just give you the formula here, but so the difference of squares, and we spoke about it in our last video, so I'm hoping you guys understand what I'm saying here. So we have a little 2 here. Let's see if I can move that down. So I'm just figuring out what squared minus what squared equals that 0. So 9x squared, let's change that. So what squared is 9? Oh, that's a 3. What squared is x squared? Oh, x, right? That one's okay. And then over here, 25, I've got what squared is 25? Oh, 5 squared is 25. Okay, and then from there, that means we have 3x plus 5 times 3x minus 5 equals 0. And then you solve each one. 3x plus 5 equals 0, and 3x minus 5 equals 0. Subtract 5, divide by 3, so you get negative 5/3. Over here, add 5, divide by 3, so you get positive 5/3. So our solution set, I'll write it over here to the right, is negative 5/3 and positive 5/3. I think if I change part of the color, that all of it changes. Oh no, that's good. Okay. That's good. Okay, so then we have our factoring practice here. You know, problems like number 5, that's your standard case. Problem like number 6 is a little bit more challenging because you have a greatest common factor. So I'll start with that one. All right, so let's say we're looking at 2x squared minus 2x minus 24. What's my greatest common factor? Oh, a 2. So then from there, I have x squared I'm sorry, I don't, the exponent button. So I'm just going to put it like that. Minus x, because I'm dividing by 2, minus 12 equals 0. So then from there, I'm finding out what multiplies to negative 12 and adds to negative 1. So that's 4 and 3. And then from there, this is really great. So I have 2 equals 0. That's just not true, right? 2 does not equal 0, so that's gone. There was an x there, and there will be when we get into polynomials. Then we would keep going. X equals 4, we would include it, I mean. So we have x equals 4, we have x plus 3 equals 0, and then you get your two solutions of positive 4 and negative 3. I like them to be in order with my saying my solution set. Smidge, like that. I hope we're feeling okay with this for a problem like number 8. Oops, sorry. For a problem like number 8, back to my blue. This is a case where I don't have a greatest common factor. So I use the slide and divide trick. Some people call it my feet don't stink. In the last video I made, I talked about my feet don't stink, so I'll reference that again. I'm going to multiply 6 times negative 4, and that's negative 24. So kind of like over here in my scrapbook, I'm finding what multiplies to negative 24 but adds to 5. Multiplies to negative 24 and adds to 5. So I think of my factors of 24, 1 and 24, 2 and 12. It's going to be a difference of 5. 3 and 8, there it is. 3 and 8 is a difference of 5. I need positives, so that means my negative 3, my negative has to be the 3. Okay. Any part of that confused you, talk to me individually, okay? So my feet don't stink, so now we're going to multiply, we did that, multiply by 6. Then we're going to factor x minus 3, x plus 8. And then we have to divide what we multiply by. So we're going to divide by 6 under the 3 and the 8. And let's see if this works. If I can like just underline it to represent dividing. Okay. And now we have to simplify. My feet don't stink. Last step is simplify. So 3/6 we change as a fraction in simpler form. 3/6 is, oh, that's 1/2. So you have x minus 1 over 2. And I'll fix that in a second. You have x plus, 8/6, got to reduce that. Oh, that's 4/3. Okay, and then we slide that number in front because we don't want to keep it as fractions, otherwise it won't be equivalent to our trinomial there. So then our final answer step, I'll write it right up here, is 2x minus 1 is my first factored form. And then 3x plus 4 equals 0. The reason why I said factored form there and kind of paused, so I want to remind myself to tell you guys that this is an example right here, 2x minus 1 times 3x plus 4, of a problem in factored form. Same right here. This is a problem in factored form. So that's valuable for a conversation we're going to have soon after this. Okay, so keep that in mind. And then we're going to solve each one, and you get two solutions. So we have x equals negative 4/3 and add 1, divide by 2, so positive 1/2. I did this other one first because I like it to be numerical order. That's just me being kind of like a stickler to myself, you know, wanting that for myself. So then for problems like 9, 10, all the back, right, all of these pages, these problems aren't equal to 0. So literally your first step is to just make them equal to 0, and then it's just what we did before. So let's jump to a problem like number 11. So problem like number 11, I'm looking at my x squareds. I have them on both sides. I want positive x squared every time. I can't stress that enough. I want it every time. So because I have more x squareds over here, I'm going to subtract x squared from both sides. I'm going to add 1 to both sides. So here, I'm subtracting my x squared. I'm adding 1. Here's my equal sign. It's still there. And then I'm subtracting x squared from my x squared, and I'm adding 1 on that side. These are large numbers. Like if here's the bridge, right? solving equations. And then these equals 0, that equals 0. So everything on the right is now just 0. And then on the left, you're just going to do the math. So 2x squared minus x squared, that's x squared. Negative 50 minus 1 is negative 49. And then that's pretty great because that's the difference of two squares. So I have x plus 7 times x minus 7, right? The difference of two squares equals 0. And then I have my two solutions, negative 7 and positive 7. Awesome. Same idea with all these. You just have to get them equal to 0. I want you to practice some of these problems. Let's finish. Why don't you guys work on, because I did a lot of the evens, why don't you guys work on the odds to finish this? I'm sorry, I drew some extra lines here. Oh, that's me canceling out. And I did want to show you one other thing. I know this video is getting a little long. Thanks for staying with me. So we can represent quadratic equations in many different ways, right? So say we have a standard form equation. I taught you how to turn that into vertex form. Well, we know how to turn it into factored form because that exists up here, right? Remember I told you, like, for example, this step right here, that's factored form. It's just instead of a 0, we'd have a y or an f of x, okay? And then you know how to graph these, all of these, because that's what we've been doing. So I want you to try some of these. Sometimes you're going to get it in vertex form. So you're going to have to put that back to standard form before you can put it in factored form. You might be able to graph quickly though. And then sometimes you're going to get in factored form. You're going to have to multiply that out to get standard form and then use our trick to convert to vertex form. There's another way we can turn it into vertex form as well, but I think that I'll show you that in class, okay? All right, great stuff today. Make sure you get all that down. Practice a couple of problems. Let's do 3, 5, 7, 9, 13, 15, and 17. So those odd questions. All right, cool. Have a good day.